So we're still going to practice solving equations. And we talked about last class, or 2 classes ago, we talked about, well, you add or subtract something from both sides, you get the variable by itself. Then we said you can multiply or divide something by both sides, you get the variable by itself. And then we said, okay, there's multiple steps you have to do to get the variable by itself. So most of the time you undo addition or subtraction first, and then you undo multiplication or division. Okay? That's not always the case, but oftentimes it is. Now we want to talk about what happens if there's a variable on both sides of the equal sign. What do we do? Okay. So we're looking at an equation like this. Okay. If I want you to solve this equation for x, okay, our goal is the same. Still get x by itself, positive on one side of the equal sign. We're trying to isolate the variable. Get x by itself. So, but the difference from these and what we were talking about last time was we have x's on both sides of the equal sign now. Before, we only had x's on one side or the other. Okay. So what we have to do is we have to get the x's together on one side of the equal sign and combine them. So we can either move this 3x to the other side of the equal sign and combine it with this one, or we can move this 7x to the other side of the equal sign and combine it with that one. You could do it either way. I always like doing it so I keep the variable positive, which meaning, how would I move this positive 3x to the other side of the equation? What would I have to do? I'd have to subtract 3x, right? So if I subtract 3x there, I subtract 3x there. Okay. You could move the 7x over to the other side. You would have to subtract 7x from both sides. The problem you would run into, though, you'd get 3 minus 7, you'd get a negative 4x. And that's okay, and you can do it that way, but the less negatives I have to deal with, the better, I think. All right. So I'm always going to, again, work top down. I'm going to work at the top, and I'm just going to keep working down until I get the variable by itself. So 3x minus 3x is 0. That's gone. I'm still left with a minus 5 or a negative 5 on this side. I'm going to rewrite everything else. I have 7x's, and I take away 3x's, so I now have positive 4x's, and I still have the minus 21. So now it becomes a problem just like we did last class, where we have the variable now by itself, we have the variable on one side, we just now need to get it by itself. So what's going to be the next step in getting this by itself? Yeah, I would undo that in subtraction first, so I'm going to add 21 to both sides. I do that, that's going to become 0, so I'm left with 4x on this side. If I'm in debt $5 and I gain $21, how many dollars do I have then? 16, right? And then finally, last step is we want to undo that multiplication by 4 to get x by itself. So we would simply divide both sides by 4. 16 divided by 4 is 4. So I got 4 equals 1x. Okay. So it was a lot of the same steps we did before. We just now have variables on both sides of the equal sign we have to combine first. Okay. If I wanted to check my answer, I could take that 4 and plug it back in here. 12 minus 5 is 7. 28 minus 21 is 7. So 7 equals 7 is true. Okay. All right. So let's try another one here. So I have 5 times the sum of x plus 2 equals 2 times the difference of 3 minus x. I want to solve this equation for x. I now have x's on both sides. But here I have some parentheses. I have some multiplication going on that I would like to simplify first. How do I simplify a multiplication problem when I have one term being multiplied by 2 terms in here? What do you do to that? Yeah, distribute, right? You're going to distribute that 5. 5 times x and 5 times 2. So I'm just going to do that step. I'm going to do one step at a time. 5 times x is 5x, and 5 times 2 is 10. Let's just say that's the only step I did right here. I'm going to rewrite everything else just like it is. So that's made it a little simpler. What would be the next step to probably simplifying this? Yeah, I would distribute that too also, because you're multiplying it. So I'd distribute that too. The left side stayed the same. 2 times 3 is 6. 2 times, that's like a negative 1, x or minus 1. 2 times minus 1 minus 2x. Then we want to get our variables on the same side of the equal sign, and if I can help it, I'm going to make it positive. So keeping my variables positive, should I move the 5x over or should I move the minus 2x over? Yeah, I'd move the minus 2x over, right? Because that would mean I'd have to add 2x to both sides. If I move the 5x over, I'd have to subtract 5x from both sides. And you could do it that way, but then you just got more negatives to deal with. So I'm going to move that 2x over to the other side by adding it. Again, I just add it here. I can't add it to the 10 because they're not like terms, right? 5x plus 2x gives me 7x. I still have the plus 10. I still have the 6, and that went away. So now I'm trying to get the variable by itself. In this case, it's easier to undo the addition first. So to undo that plus 10, I'd subtract 10. I get 7x equals, if you have $6, you take away 10, you're now in debt $4. And then what would be my last step here in solving for x? Yep, divide both by 7, right? Undo that multiplication by 7, divide both by 7. So I'd have x equals negative 4 over 7. Happens to be a fraction, that's okay. You get fractional answers, no problem. Give that one a shot, then we'll check our answer together. But what would be probably our best first thing to do here? What would be the best option to do first here to start simplifying? Yeah, Marissa.
Multiply 3.
Yeah, I would multiply that 3, get rid of those parentheses, right? When you use distributive property, you can then remove the parentheses. So let's go ahead and multiply that 3 into both those terms. So the left side stayed the same. I'm just going to rewrite it. 3 times 6 is 18. I treat it as 3 times negative 2 is negative 6x, or minus 6x. Okay. I'm always looking to see if there's any like terms on both sides of the equal sign that I can combine first. And in this case, there's not. Okay. So I'm just going to try to get the variables together. Which way is going to keep my variables positive? What? Yeah, if I add that 6x, right? Because that's a minus 6x. Again, you can subtract the 8x, but that's going to make them negative. So let's add the 6x to both sides. That 8x plus 6x is 14x. I still have the minus 10. I still have the equal, and I still have the 18, and that went away. Now it becomes a problem very similar to what we've done before. We're going to undo that subtraction by 10 and add 10 to both sides. And I get 14x equals 28 before dividing by both sides by 14 to undo that multiplication by 14, the inverse operation, get x is 2. How we do with that? Get that? Yeah? Good. All right, let's say you're given this equation. You're supposed to solve for x. So we're going to continue like normal. We're going to go ahead and distribute that 2 to try and get rid of those parentheses, or to multiply that 2 in. So the left side stayed the same. Equals 2 times 5 is 10. 2 times 7x, or positive 7x, is positive 14x. And then I have that minus 4 tacked down on the end. I want to look here, are there any like terms on the left side of the equal sign to combine? There aren't, because those aren't like terms, right? On the right side of the equal sign, though, I have like terms. What are they?
10 and 4.
Yeah, 10 and minus 4, right? So you can go ahead and just combine those, make the problem smaller, right? So I'll leave the left side the same. If I have 10 and I take away 4, because it's minus 4, so it leaves me with positive 6. I could have wrote 14x plus 6 too. It doesn't matter where the 6 goes as long as it's positive. So now it looks like a problem we've done before. We're going to get those 14x's together on the same side of the equal sign. They're both positive, so if I subtract 14x here, I'm going to subtract 14x here. Well, all of a sudden that's going to leave me with 0x. I'm left with 6. I'm still left with 6 here. And that leaves me with 0. So my variables here have disappeared, right? I have no more variables. And all I'm left with is 6 equals 6. Which that's a true statement, right? 6 does equal 6. But my variables are gone. I don't have x equals something like I did before. If this happens where the variables go away and you're left with something that's true, we call that infinite solutions of this problem for x. We call it infinite solution. What's it mean for infinite? What's infinite mean? Yeah, forever, right? Infinite amount, never ending. There are a never ending amount of things you can plug in for x that make this problem true. Okay? You can plug in anything you want for x and it's going to make this problem true. Okay? And I know that because I was solving this equation and x went away and I got something that was true itself. We also call this the identity. That's not super important right now. But there are infinite solutions for x here. So let's see why there are infinite solutions. Let's just pick something to plug in for x and see what happens. Let's pick 1. 1's going to be really easy, right? So if I plug in 14 times 1 plus 6 equals 2, parenthesis, 5 plus 7 times 1 minus 4. So I have to do order of operations here. 14 plus 6, that's 20. And on this side, that's 7. 5 plus 7 is 12. And 12 times 2 is 24. So I get 24 minus 4. And I get 20 equals 20, which is a true statement, right? And I plugged in 1 for x. If I went back to that problem, but let's say, okay, instead of plugging in 1, let's plug in 0. Because according to this, I should be able to plug in anything and it'll always be true. 14 times 0 is 0. I get 0 plus 6. 7 times 0 is 0. 5 plus 0 is 0. And 5 plus 0 is 5, I mean. And 2 times 5 is 10. I get 10 minus 4. I get 6 equals 6. That's also true. And I could just keep going. I could keep plugging stuff in for x, and I'm always going to get a true statement here. That's what it means to have infinite solutions. There's not just one answer x can be to make this true. There are an infinite amount. Any questions with that? Go ahead and try and solve this one as far as you can and see what happens. Double check that that was your first step. We distributed that 5 to get rid of the parentheses. At this point, there's a lot of different directions you could go, but since I have like terms that are on the same side of the equal sign, I'm going to go ahead and combine those. You don't have to do that next, but I'm going to because it's going to make the problem a little bit smaller. So the left side stayed the same. I had 5x and I took away 3x, so I'm going to get 2x. Okay. Then I'm going to combine the two x's. I'm going to get those on the same side of the equal sign. So it's a positive 2x. So I'm going to subtract it from both sides. That went away, and now I'm left with 5 equals negative 35, which that's a false statement, right? 5 does not equal negative 35. It never does. 5 equals 5. Right? So when this happens, and your variables disappear and you're left with a false statement, we call that no solutions. There are no solutions to this problem. There's nothing that you can plug in for x that would make this equation true. Because whatever you plug in, it's going to give you something at the end that's false. So since I got the variables went away and I got something false at the end, that meant it was no solutions, whereas the previous problem, I got something true at the end, and there were infinite solutions. Okay. And then the problem before that, we got just one solution. We got x equals 2. All right, so there I have one solution, infinite amount of solutions x could be, or no solutions x can be if I get a false statement at the end. Okay. Algebraic equation here, right? Algebraic equation. Trying to solve for x. I want to solve for x. But I have some fractions mixed in here now. I have division. Okay. This problem is going to be a lot easier if I get rid of this division. Right? It'll be a lot easier if I get rid of this division. Okay. So what's the inverse operation of dividing by something? Yeah, multiplying, right? So if I want to get rid, let's say, for example, of this division by 8, I can multiply that side by 8, and those will cancel each other. But whatever you do to one side, you have to do to the other side. You can do whatever you want to either side as long as you do it to each side. Okay? So on this side, I'd be left with x plus 1 because I got rid of that fraction. So that just made that side a whole lot easier. It's now just x plus 1 because I got rid of the division by 8. I simplified it. On this side, I'm going to go ahead and multiply these together. So since they're fraction, I'm going to put 8 over 1. Because when you multiply fractions, you just multiply the numerators together and multiply the denominators together. Right? 8, or x times 8 is just going to be 8x. We just write the coefficient or the number in front of the variable. And 4 times 1 is 4. So that already looks a lot easier than the previous problem. Okay? You might recognize that you can take 8 divided by 4 and make this 2x, right? You could do that, and that would be a perfectly good way to do it. But let's say you forgot about that, and let's just say, well, I just want to get rid of this division by 4 because I don't want to deal with any fractions here. So to get rid of a division by 4, we would multiply by 4. When you multiply that by 4, those will cancel, and then you have to do it to this side. But here's the difference. You have to multiply all of this by 4, right? You have to multiply all of this by 4. So I'm going to put this in parentheses to remind me that I need to take 4 times all of that. Whatever I do to one side, I have to do to the other. So on the right side, now I'm just left with 8x. On the left side, I need to go ahead and distribute this 4. I need to multiply it to everything. So 4 times x is 4x. And 4 times 1 is going to give me positive 1, positive 4. So I just changed this problem to dealing with a bunch of fractions and something that look a little messy to 4x plus 4 equals 8x because I got rid of the fractions by doing the inverse operation. So now I want to get my variables together on one side of the equal sign. It's going to be easier if I move this 4x to the other side. And I can do that by subtracting it. That goes away. That leaves me with 4 equals 4x because 8x minus 4x is 4. And I know that's kind of small there, but then you would divide both sides by 4, and 4 divided by 4 is 1. Okay? And I get x equals 1. If I wanted to check my answer, 1 plus 1 is 2. That's 2 over 8, which simplifies to 1/4. If I plugged in 1 here, that'd be 1/4. I'd get 1/4 equals 1/4, so that is true.